Innovation in agriculture isn't just good business. It directly addresses one of humanity's greatest challenges: how to feed a growing population in an environmentally sustainable and socially responsible way. Lives depend on it. Every day, the global population rises by 200,000. Over the next 50 years, we're going to have to feed 2.5 billion more people, which means that we must achieve the efficiency required to produce more food than we produced over these last 10,000 years. But that's not all. We must also find a way to feed the world without further stressing the planet, without requiring large increases in cultivated land, water, or other inputs, all while protecting nature and improving the livelihoods for people in rural communities. Collectively, we must take this responsibility.
Responsibly increasing productivity is no easy task. Our breeders are on a hunt for seeds with inherently higher yields. A soybean's 46,000 genes determine its potential, and the design of a crossbreeding program involves hundreds of interrelated decisions, producing millions upon millions of possibilities. The centuries-old trial and error method of crossbreeding plants is no longer viable, but there's no way to comprehend it all without analytics. So our soybean research and development team created a suite of 4 operations research tools.
I admit I was a skeptic at first. I couldn't see how computer program code could possibly help me make better decisions in the field and the greenhouse where we do our work. But as I worked with the code writers, I began to get an appreciation for new insights they were giving me into my own project. And I quickly saw that the tools they were developing would bring better ability to make better decisions. Decisions that were going to be based more on mathematics and probability than simply experience and intuition as it had been before.
Our breeding project lead tool helps the breeder get the mix of times and locations of experiments right. A yield trial design optimizer manages the complexity of a global growing operation. A trait introgression tool models the complex genetic questions of how to cross-plant varieties to maximize genetic gain. And our data quality cart tool uses visualization to filter out environmental noise from field data. To achieve the results we've seen from using these tools, we would have had to spend an extra $287 million on our soybean breeding program. But the results won't stop there.
The power of analytics is truly transformational for agriculture. Not only is it helping us advance our good growth plan commitments, it's helping Syngenta's bottom line as well. In other words, operations research breeds success. And, of course, these techniques don't just work for soybeans. Last year, Syngenta's R&D leaders launched an initiative to implement these successful operations research tools across Syngenta's crop platform, using customized versions for corn, for sunflower, rice, and even watermelon. We hope to have this initiative complete in 2018. We've seen the value of analytics, and our future depends on it. In fact, everyone's future depends on it.